taking his place and doing a little presentation for you guys. Be aware that's actually the slides submitted by him. He's our FHE research lead, so this could be very dry and very technical. But myself is at the more like a business side, so I'm just gonna talk a little bit more like, you know, the applications or, you know, the use case or some like, you know, fun stuff. All right. So anyway, what is the Verisense? Okay, sure. So Verisense is a FHE-enabled validation as a service platform. What does that mean? We're actually at the restaking tracks. We believe that Eigenlayer started at chapter 1, but really just kind of open the book and display any interesting real use case that validated the business model. And we believe the real use case that can possibly validate the business model of the entire restaking is not at the current decentralized apps or the decentralized networks in the existing general purpose L1. It must be some heterogeneous, you know, DApps that are not being able to serve well in the general purpose L1 blockchain. Hence, they are motivated looking for new applications, new infrastructure, and possibly pay for that. So Verisense built a heterogeneous network with a customized validation concepts, and this is actually using a little bit FHE enablement. So again, yeah, we're not at the computation level, right? We're more at the application level, which, you know, demonstrate how FHE might be kind of, you know, helpful for the future application. So before I get into the FHE component, I probably need to explain a little bit about the general concepts of the restaking. Often people asking me a few questions. The first one is that, so what is really restaking, right? Isn't that restaking just some fancy terms for DeFi or a cunning way to get a little bit more rewards? Well, yes and no. Yes, that's because we do observe this, right? That at this side, oh, where's the pointer? No. No pointer? Okay. So I'm just going to demonstrate here, right? At the left side, you see that Eigenlayer or a couple other restaking partners are already doing a pretty good job to demonstrate they pull together all the valuable tokens as collateral to supply the security origin. Okay? So that's pulled together. However, nobody right now is really focused on restructure and redistribute the security origin, allocate the proper amount of the security origin to the right ABS or towards ABS, you know, that varies a lot in terms of their business natures, security needs, right, their affordabilities, and even the decentralization degrees, okay? So without this component, you could hardly believe the whole restaking story or this money flow what works. That is where we are at this moment. That's where people think, all right, restaking possibly goes nowhere. We think, no, 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 we just get started. So this is a restructure components. But then the second question people may ask, all right, so what's the big deal over the restaking for shared security? Isn't that any other general purpose L1 is already about shared security, right? We believe that, you know, ooh, this is not really working for me. I think this is not working. It cannot goes back. Oh, okay. Sorry about that, guys. Okay, yeah, I got it. That is because we believe that general purpose L1 is providing shared security, but then also all the layers on the top, layer 2, right, whether this ZK EVM or FHE EVM or all the application built on top of that, is also inherit the limitation of the underlying layers, right? Restaking security is actually different. They allow you to work, you know, or support the heterogeneous network parallelly, very, very flexibly. So that means at the same time, it provides the shared security from some large protocols with very, very valuable tokens. At the same time, it's also allow you to have this flexibility to work on your own networks, whether it's a heterogeneous network or EVM equivalent homogeneous networks. So this is the amazing part. So that's why the Verisense is working on this kind of like dedicated on working this part, and we believe once we have this heterogeneous network that we're able to onboard some interesting applications. Okay, so then comes to here. People will, oh, okay, fine, that sounds interesting, but then where is the FHE things, right? Since today is an encryption day, right? We believe that the most possible use case for AVS or restaking is often for smaller network. Because once its application grows to the quite a larger size, they may possibly use their own network. So then, small network often get challenged for being less secure. What do? So we're gonna have some FHE layers to add on the security layer. So in Verisense that we actually have the 2 layers network. One is the host net. Imagine all the validators as a POS chain, right? And then each validator can actually work as actors. That multiple active actors come up with a working clusters and serving as the validation as a service platform for any upcoming matching AVS. And then this AVS network, essentially the subnet, right, in our systems, they could be very small, starting from 3-5 nodes, just allow the AVS application being on board with the restaking platform with a very, very affordable price. Okay. So then we basically use the FHE VRF for node elections and blind voting for slashing mechanisms, because we find that those are very relevant components to use FHE to support new protocols or like customize the consensus and applications. So VRF is quite simple. It's because I guess people know that once a user kind of like give a seed, and then the validator would probably use a hash proof, right? But in our case, user and a node are the same parties, so that leaving the collusion room. In order to avoid this, so we just kind of like implement a FHE enabled VRF just to make it a little more secure. So I don't think we have to go through those, because the idea is like basically make it a VRF more secure. And the second thing is that we build a monoring protocol. As I mentioned, that we use a layer of a blind voting. I think I'm gonna skip the slides because I've already made a point, right? We need a different consensus mechanism because we're building a actor model-based heterogeneous network focused on onboarding some new applications. For example, right, the large-scale Web 2 social applications, or some FHE-enabled applications, or some decentralized AI agent. So I'm just gonna skip this. So the topology of the AVS consensus or network in our system is very much look like a token ring model, which was initially proposed by IBM. This is actually used often in the communication networks, in the communication industries, for the heavy load networks that are required to reach quick consensus. So we utilize this model. You can tell from this, right? Let's say I have 5 actors to form a network. Only the active actor, or let me put it this way, only the actor that assign the token is able to do the local workload. For example, signing up something, or issue some transactions, right? And then once they finish everything, the local workload, they attach with the token and pass down to the second actor. And the second actor do their stuff, and then just move to the next station. So once they finish the whole ring, they upload the consensus to the hostnet to achieve a permanent finalization. Okay, so by doing this, you guys can tell our consensus is able to provide a shrinkable or expandable network towards the AVS who are having different, who are requesting for different degree of decentralization or with different, affordability, right? But then you will see some smart audience down there would say, all right, so then that seems like, if the actor 1 and 2 vote yes for certain transaction, 3, 4 vote for no for the same transaction, what leaves actor number 5 to do, right? It's a swing state, and then that leaves a huge collusion or bribery to actor number 5. So how do we do that? We need somehow to turn this perfect information game into imperfect information game by wrapping up the voter's ID and voters' results, and until the last moment, nobody sees everybody else's votes. That's how we get rid of the second-hand mover advantage, right? So that's why you see that in our protocol, because AVS most likely would support or requires a smaller network, and then also requires to reach a very quick consensus in order to support those Web 2 applications, we need to use a token ring type of the network. Then because we use this a token ring type of network, there is clearly a second-hand mover advantage. So then, how do we resolve that, right? FHE, very, very natural answer. I'm gonna skip some of this here. So we got this inspiration from a long time ago, a curve DEX called a VE33. It talks about a 3-body kind of a gaming theories that, if everybody sees everybody's action, then quickly, if somebody did something bad and tried to move money out, everybody else follows, then quickly you lost your natural equilibrium from the VE33 goes to VE -3 -3. So we want to avoid this, right? And then we actually use a FHE implementation to build a blind voting. So it's possible that we may use some existing components from the open source library, or possibly we're going to just use Fhenix blind voting functionalities. So that makes us possibly onboarding with the Fhenix as a early ecosystem projects. Okay. So those are some technical stuff that I will leave this, for the folks that want to know more about the details. So I'm just going to skip that. I have a little demos to share with you. This is about a real developer forums. As I mentioned, that we believe the paid AVS comes from some new applications. For example, larger scale Web 2 application. So then we found a forum with 7,000 real developer users, about 15,000 posts. Their daily active page view is about 1,500. And then they're looking for a decentralized platform. So then they found us, they onboard with us, and we actually, have a little demo to show how this developer forum that built on a decentralized platform, and we even give them a very interesting decentralized AI agent that basically, initiate the API call to the OpenAI and return the message and reach the consensus. Hey, can you help me to play with that? Oops. If it's not working, then we can probably scan the QR code here, because originally we were required to submit, a PDF document to present, which makes the playing video is impossible. Right now, I was just switching to my PPT mode, and hopefully, it'll work. But if it's not, then we have the fallback, the second option. Let's just, scan this QR code. Does it work? No? Sorry, yeah. So I guess if it's not work, then we can just scan the QR code. I also have a very new update that we found another decentralized applications They are basically the concept of a short drama application, meaning bunch of friends, silly friends. They write up their own story, write up their own scripts, and then they hired their own friends, possibly as a crew or cast, and then shoot a video, and then release the video, and then they issue the meme token. If the view number or the hits of those community-driven videos reach certain consensus or reach certain threshold of the hits, so then they got a huge success for this first episode. But the second episode just quickly, got warning from a centralized video streaming platform because, come on, it's a community-driven or community-made videos. So often, it might kind of reach to some like a semi-sensitive red line, right? So they realize that if they want to have a sustainable business model, they need to find a decentralized platform, make it, unstoppable. And then they are onboarding with Verisense. So that means that, with those FHE implementations, restaking models, right, and Verisense that focus on this restructuring and redistributing of security origin, now it's possible we're going to have decentralized TikTok, decentralized OnlyFans, and we founded those instances and applications. No, I think I'm good. Oh, it doesn't work anymore. So yeah, if you guys will have more questions or interested in Verisense, come to talk with me. I'll be here, for a few more minutes. All right. Thank you, guys.
All right, guys, thank you so much. We are done with Encryption Day. Thank you so much for staying till the end. We will be doing a hackathon starting tomorrow, ETH Globals. We have a 5K prize, so participate. And also want a special thanks to B for managing this entire event. Yeah, great job, everyone, and thank you. Yeah, of course.